Hello, my name is Qiming, and this is my final presentation. Last time we doing some need analysis and concept exploration for the high-speed rail system. So this time let's talk about the advanced development or the engineering design. Yeah, it's easy to understand that the rail system is very complex. It has many subsystems, so such as the track, right? The train is running on the track, and the train body and the train control system, and also some the internet, right? There are many subsystems. First, the most important, let's look at the train. The train is very complex. It has many parts. It has some technology part. It has some engineering part. It has the relationship with many fields of the engineering, right? So let's talk about the technology it used and the design. There are many parts of the train. So, for example, the traction control system and the train body. Yeah, the train body is very important. You can to imagine that the EMU train is 300 kilometers per hour, and the general train running on the China track is 100 kilometers per hour. So such a high speed we must make the train body more tough, right? And other subsystems such as there are many sporting facilities is also important. It has many changes from the general trains. We will talk about that sooner. And many other subsystems. The first and more important one is the traction control system. The traction control system is it can divide it into many parts. For example, the main converter, the traction transformer, the traction motor, and traction drive control. It has many facilities also. So the high power electronic traction drive system is the driving force of high-speed trains, right? So since the basic resistance of a high-speed train is what is a air resistance, right? So it can be roughly considered that the basic resistance is proportional to the square of the p, right? The square of the p. For example, the speed is 300 kilometers per hour. So we also so the basic resistance is proportional to the square of this speed, and the required power, the power is proportional to the third power of the speed, the third power, right? So why we need to do that? We need to, if the power is only equal to the, if the power is only equals to the resistance, it can only to running in a specific speed. But if we need to get the train to have acceleration, we need to get to the third power of the speed, right? So the required power is more than 15 times that of 15 times of 100 kilometer speed train, right? If we have 100 kilometers per hour, and this is 3 So it has 15 times. So such a large increase in power means that a large number of applications of new technologies. Therefore, the electric traction drive system of high-speed EMU trains must develop in the direction of large power. We need large power and lightweight, small size, and high reliability and low cost. This determines that the electric traction drive system of high-speed EMU trains must adopt advanced AC/DC AC/DC transmission system. It mainly includes the main converter, right, and the traction transformer, and traction motor, and the drive control. Yes, the main converter. Adopting new high-power semiconductor devices, from the earliest thyristors to GTO and IGBT, IPM, and even IGCT. The development goal of the main converter is minimize the weight and for energy saving and environmental protection, reliability, and also economical application. So, and then the traction transformer and traction motor. The traction transformer is the component with the largest weight of the system. It has the largest weight and largest volume and largest energy consumption in the traction drive system. And the traction motor, actually most modern high-speed trains use the three-phase AC traction motors. So compared to the DC motors, they have the characteristic of lightweight, large power, and simple structure, and reliable operation, long life, and even maintenance. So we must use the AC motors, right? We can't use the DC. So the traction drive system. The level of traction drive control depends on the strategy that developed from the initial control system to the vector conversion control. So it's very complex. We will discuss this later. So there are also other technologies we need to meet the need of high speed, right? And also important, it's connected to the traction control, is high-speed braking technology. It's easy to understand that the braking system of a train is a guarantee for high speed and safe operation of trains, because we can easily understand the safe is very important. So the braking technology is hard and also important. Why it's hard? Because it needs the more power to braking, right? And there are many parts, many separate technology. For example, the basic braking technology, the dynamic braking technology, and the compound braking technology. And also this is very important, non-adhesive braking technology and anti-skid control technology. The braking technology of high-speed trains must solve the problems of a rapid conversion of train kinetic energy and energy consumption, and achieve reliable stopping or landing of high-speed EMU trains under the conditions of allowable wheel-rail adhesion. And in addition, because the wheel-rail adhesion coefficient decreases with the increases of the operating speed, it further increases the difficulty of high-speed braking technology. So, at present, the key technology for high-speed train is very hard.